My name is Tatyana Tsvetovat. Nobody can pronounce my last name. It's courtesy of my husband. I went from Fisher to Spatially, so it's, yeah, trust me, it's true love. I am a data scientist in Booz Allen Hamilton. Yes, another capital Beltway bandit. And my journey to data science actually was very unusual, and in a million years, I would have never expected to be a coder. I was a political scientist by training, working as a contractor, working with a lot of data, and actually taking that data to coders to make some sense out of it. And frankly, I got tired of that because they could never understand my data. They couldn't understand why one cluster was important than the other, what the outliers were, why something was important. So I said to myself, well, why am I talking to you guys? I'll just go out and code. In comes Mark Weissman with his data community in DC, with his fantastic newsletter and a whole bunch of local meetups. So I started going to Pi Ladies, so Jackie Kazel, Katie Cunningham. I checked out some groups that did R, and I figured, why don't I just start with both? As long as I master the basics, I should be good. Well, duh, we all know what R is, but by now, if you don't, sorry. I support several federal customers, let's leave it at that, and a lot of my customers work with spatial data. How did I start doing spatial R? So when I first started, I never worked with spatial data in R or Python in my life. I always stuck with something being more traditional statistics, the works. Until one time, I had an urgent project where we had to use Arc Pro. Are you guys familiar with Arc Pro? GIS tools? Yeah. We all love them. And of course, the worst time ever, on a strictest deadline, it failed. It failed to launch. It wouldn't start, it would crash. And I did not have a big data set. It did not have a database as a shaper. I couldn't even open the data. So given 2 days, I had to find another way of how can I even look at the data, what's inside. So Google is your help. You Google say, okay, spatial analysis, and in come a lot of these awesome tutorials from Robin Lovelace, from Zaya Frost, where they talk everything about R. Like, oh my God, I can actually look at my data. So that's how I came about starting spatially with R, and created apparently quite a niche within my team, who was like, oh my God, you can do all this stuff with something that we always thought was traditional statistical analysis. Let's look at correlation and regression. We can actually use geodatabases and shapefiles for that. Awesome. There are so many fantastic packages in R. I love them. It's like every time a new package comes out or there is an update, it's literally the highlight of my day. Well, that and my child's performance at school. True. I get daily phone calls, guys. Not his father, the Pythonite, the R person gets the daily phone calls. Yeah. So what I love about R is, first of all, I love the interface. I'm an RStudio devotee. I'm not saying this because they're the sponsor. I really do RStudio. I have apparently turned a lot of people on my team to love RStudio as much as I do, and not do just do the old school command line, leave us alone. And of course, Jupyter. By the way, guys, if you have never used Jupyter, Jupyter does have the R kernel. It's pretty interactive. You can upload your code. The graphics are great. They're huge. So for someone who is as nearsighted as me, it's fantastic. I love the model environment. I love how you can do all kinds of spatial temporal analysis. These are just some of my favorite packages. I honestly can do the whole presentation just talking about which packages I liked and don't like. But these are the ones I use all the time. RGDAL, I would be lost without it. I can't do my work without RGDAL. If RGDAL is not updated in my system, I am in trouble. If you're ever working with geometries, RGOS is your next big thing. It's what I love about both these packages. If you run them together, it's literally one line of code. You have all your layers. You have everything. If you're working with statistics, because hey, R is after all it was founded as a statistical tool. SP and GStat and SPATStat are fantastic. Kern Lab, I actually recently discovered a package, and it was awesome. I had to do spatial regression using some spatial temporal data, and it did the work famously. It was so clean, lots of great examples. Okay. Look, guys, let's be honest. All programming languages, there are some good stuff about them. There are some not so good about them. These are what I call Tatyana's list of pros and cons. You can use R or Python or whatever language you want for your analysis. Here's what I found it to be great with. I love the CLI. You can do the workflow. You can see actually what you're doing and how you can code it up and how you can work with algorithms. The graphics. I've heard some people before, especially the critics, saying, the graphics are boring. They're not. They get the job done. In the end, let's be honest, we all post this on PowerPoints to our customers because they, especially the federal clients, because they are too afraid to look at our Jupyter notebooks and they don't want to mess them up. The functions or spatial packages. That is one of my favorite things. If I were to code this stuff in GeoPandas, anybody knows GeoPandas or Spatial? These are the top geospatial packages in Python. They deal with data manipulation, they deal with spatial processing. They're great, they get the job done. But if I want to do data manipulations in Python of spatial data, it will make me do a lot of coding. I'm a lazy person, I don't like to write a lot of code. I like when I can just do with just a few lines of code and get the job done. So you have a lot of functions. And it doesn't just for spatial. I do also a lot of time series. I love doing time series in R. I actually specifically request from my customers, like, can I please do this in R? Will you mind? Yes, multiple functions, variety packages. But it is still not perfect. There is no such thing as a perfect language. And the cons. You have a lot of libraries in R. I mean, a lot. And sometimes you need to, in order to get the job done, you will need to upload, I think one time I had up to 30 libraries just to get the job done, to do all of my analysis, and it's a lot. And it's not always updated with the most recent version of R. So if you try to run it, you will get, oh yeah, that function has deprecated, but this doesn't work, so you got to fix this and install that to do this. Oh, I don't have time. If you guys all know about the data sets. A lot of the spatial packages will have preloaded data sets that you can practice with. What I found the hard way was you don't have preloaded maps of every single country. All of the European countries are there, African countries are there, but if your customer wants you to look at drought in the Philippines, you're kind of screwed. So what I found is you have to find a map overlay from someone else, either a digital boundary library in your agency or upload it from somewhere else, which requires extra coding. I know some people are going to kill me for this. Not going to like it. How dare you criticize 3D capabilities of R? Not always there. I love working with network analysis and network 3D and in Neo4j. They're great. But if I were to do an interactive presentation for my customers, I would go with linking my R or Python to Tableau or to Plotly. Tableau, I know it's not the perfect way because you have to get a license, but Plotly is free, especially if you have a server and you can get the job done. And if you're trying to zoom in into your maps, Leaflet, I found it to be sometimes kind of spotty, so take it, leave it. Again, it's my personal experience. I know people swear by Leaflet, great, but that's what I had. Here's just some of the type of spatial analysis I have done. Anything from, hey, we want to look at where different cell towers are located within the country. Are they in the insurgent area versus in the government-controlled area? If you are trying to learn spatial R and if you're looking for really great open source data to play with, I go to my 4 top sources whenever I'm learning a new package. I go to ACLED, which is the ARM conflict language. Sorry, armed conflict location events database. It's fantastic. They have a lot of notebooks you can play with. Then there's also GDELT, which is updated every 24 hours, and you can pull data by Google Query. GDELT, it's your social media, it's your media, and there's several tutorials, by the way, online you can look at, especially if you're trying to do network analysis or data manipulation of the data, because the data can be a little bit complicated. I also like, thank God some of our federal agencies still keep the open source data, so national parks, great data to play with. And I recently found out that some of the DHS data sets apparently are available. So if you're looking for infrastructure, you can pull that too. So here are just some of the most basic visualizations that I have done. This is looking at cell towers locations within the US and around the world. Here's my favorite data set. I love working with ACLED. And I have also turned some of my customers to work with ACLED whenever they're learning and looking at conflicts and refugee movements. This is actually looking at fatalities in 4 countries around the Great Lakes region in Africa. So from 2000 all the way to 2016. And what I love about that data, it's always updated. So if you have additional analysis from other sources, this is a great supplement. They love seeing that. Timeseries, oh my God, highlight of my day. I cannot imagine my data science life without doing Timeseries. In fact, that's one of the things they bring you for. Like, can you do a Timeseries analysis? We don't know what it is, but can you just do it? So if there's spatial temporal data, I just go, yeah, let's see how these guys are moving, the bad guys, the good guys, where they are at, and most importantly, can we predict the future? R has by far some of the best time series packages. I'm not just talking about Zoo or XTS. It's fantastic, and it works great with spatial data and already preset functions to clean the data. Here is a data set. This is, I try to replicate my work for the customer using vehicular data, where they're moving within a particular time period, from 2012 all the way to 2016. Nice and clean. And spatial clustering. Before I became a data scientist, my clustering was always involved with a role of people. So if you're doing, say if you're doing terrorist networks, for example, they have data available online, but this time I was allowed to add the spatial aspect, and it was great. Where are these guys moving? Where are these insurgent groups moving? So this is also ACLED data, and I'm looking at 3 different insurgent groups in support, splinter groups for Boko Haram. I wanted to see what the clusters are. Are they small? Are they big? Which was like, okay, they're pretty much all the same. There is so much you can do when it comes to R and spatial, and you can take it to the whole next level. And if somebody tells you, well, Python can do it better, maybe it can. Just for me, if I'm doing statistics of spatial data, I stick with R, and that's my preference. Take or leave it. And I'm done. I'm giving you guys back 5 minutes. Here is my, can I do my contact information? No, really. Yes. Seriously, Tatyana, you can't type. It should have said data scientist, but my email address is there. I would love for questions. Email me, call me. I'm DC based. If you're ever in Tyson's Corner, holler. I would love to come out. I need an excuse to stick to someone. As you cannot go train for your Ironman. I'm going out to meet with some smart people. So, thank you.